Good evening. These are the notes for Wednesday, October the 4th. The learning target today was the same as yesterday. I can determine the zeros of a polynomial function. Okay. So we're going to do a couple examples today. I'm going to do 3 examples. This first one, this is not a notebook. This was a handout I gave today. But this first one, we're going to look at this one. It's a quartic polynomial. Remember, we have a major test coming up on Friday. Okay, so I have a quartic. I'm going to zoom out a little bit so it's not right up here. Okay. So I can determine the zeros of the polynomial. We're looking at this quartic. The first thing you need to ask yourself every time, guys, is can I factor that? Because if you can factor it, then you're going to factor it. But if you can't, you got to look for other toolkit strategies. Right here, I cannot factor this, and I cannot use the quadratic formula because it is not quadratic. So this is where you get your calculator out and you graph this function. But before we do that, never mind. I'm going to go ahead and graph it. We have 6x to the 4th minus 23x, here, 6x to the 4th minus 23x cubed minus 13x squared plus 32x plus 16. You're going to graph this particular function. And if you look, it crosses clearly at -1. At -1. Now you can use your table function, second table, and check at -1. I'm going to highlight -1. If you highlight -1 and come across, you see there's 0 by -1. So you know that that is a 0. So I'm going to start making a list of zeros. So I know -1. Now I'm going to use this 0 to break this down. To continue, I want to break this down to either I can factor it or it's quadratic and I can use the quadratic formula. Use that 0, bring it down, and do synthetic division. Alright, now it went from a quartic to a cubic. So I'm going to use synthetic division again, bringing this down. These values, because it is 6x cubed minus 29x squared plus 16 plus 16. So I'm going to go back to my graph and I'm going to find another 0. And it looks like 4. So I'm going to check my table to see if 4 is indeed a 0. And I look and there's 4. That is a 0. So I'm going to write 4 in my list of zeros and break it down again. Okay. Now I went from quartic, cubic, now I'm quadratic. So I'm going to write this as a quadratic. 6x squared minus 5x minus 4 equals 0. Okay, now I'm going to either try to factor it or use the quadratic formula. This appears to be bust them up. So I'm going to multiply 6 times -4. It's got to multiply to give me -24, add to give me -5. Where those two numbers are -8 and +3. So I'm going to use bust them up. I'm going to take a 2x out. That leaves a 3x minus 4. Take a 1 out. That leaves 3x minus 4. Now I'm going to set both those equal to 0. So I got 2x plus 1 equals 0. and 3x minus 4 equals 0. So x equals negative 1/2 and x equals 4/3. Sorry, let me show you that. Alright, so in addition to these two zeros, I found the other two, negative 1/2 and 4/3. So those are my actual zeros for this quartic polynomial. I could have up to 4 zeros because the fundamental theorem of algebra states that, and I had indeed had 4. These are my 4. That is where it crosses the x-axis. These are the zeros. Okay, let's look at another one. I have a cubic function here. First I'll try to see factor. If I was to group this, because it's 4 terms, I would not get the same thing in both parentheses. I would take an x squared out, I'll get x minus 2. Well, there's no way I'm going to get x minus 2 over here, so I know I cannot factor. So I'm going to graph on and take my calculator, clear the original one out. X cubed minus 2x squared plus 2x minus 1. And I will graph this function. And you see that it goes to the value of 1. So I'm going to make my zero list. Start with 1. I'm going to break this cubic down to a quadratic so I could either factor it or do quadratic formula. Right, set up my synthetic division. Bring the first one down. 1 times 1 is 1. 1 times negative 1 is negative 1. I should get a remainder of 0, and in fact I did. Now I'm going to rewrite this quadratic. This will be x squared minus x plus 1 equals 0. It appears to be easy. I'm really wishing it was, but in fact you cannot factor this. So I'm forced to use the quadratic formula. So opposite of b plus or minus b squared minus 4ac over 2a. Opposite of b, opposite of negative 1 is positive 1, plus or minus negative 1 squared minus 4 times 1 times 1, all over 2 times 1. And I come up with 1 plus or minus square root of negative 3. There's a negative in the radical, so therefore this solution will be complex because it involves an I. So I'm going to simplify 1 plus or minus. I take an I out to take into account for that negative, so it's 1 plus or minus I squared root of 3 over 2. So these are two zeros right here, the 1 plus and the 1 minus right here. So I'm going to go back to my list. 1 plus or minus I squared root of 3 over 2. So I have 3 zeros. 1, 2, 3. 1 real, 2 complex. Together, that equals 3. So, when do I go to my calculator and pick one off? When you cannot factor it or break it down to a quadratic. You have to keep breaking it down. Alright, so let's look at one more. So I'm going to have to do this on a graph paper. Alright. So I have y equals 3x to the 5th minus 14x to the 4th minus 14x cubed plus 36x squared plus 43x plus 10. That's a plus 36. Alright, now this is a quintic. It can have up to 5 zeros. I cannot factor this, so I'm going to input this into my calculator. Three x to the 5th minus 14x to the 4th minus 14x cubed plus 36x squared plus 43x plus 10. I'm going to graph this. It clearly touches at -1, so I'm going to use that, start my zero list. -1. I'm going to break this down, break this quintic into a quartic. Do your synthetic division. Okay, so now I have this. This would form a quartic. 3x to the 4 minus 17x cubed, and so forth. Now I'm going to pick another 0. Clearly crosses at 2. I'm going to come over here and I'm going to put them under. So I got -1 and 2 so far. There's my -1, 0. Now I'm going to use 2. Bring this down. Bring that 3 down. 2 times 3 is 6. 2 times -11 is -22. 2 times -19 is -38. Alright, now I went from a quintic to a quartic to a cubic. Okay? Now I need that cubic to keep on going to a quadratic. So I'm going to bring it down and pick another 0 off that graph. And I clearly it crosses at 5. So I'm going to put that in my list up here and use 5 to break it down. Now, I can write this as a quadratic. I'm going to try to factor it. I'm going to use bust them up. Try to use, it's got to multiply to give you 3, add to give you 4. Well, that's 3 and 1. Take a 1 out. So then both equal to 0. You get x equals -1/3 and x equals -1. Well, -1 is already in my list. That means there's a multiplicity of 2. So I only need to put the -1/3. So I have 1, 2, 3, 4 zeros total. I could have up to a maximum of 5. I have 4, and they're all real. So this is how you handle how to determine the zeros of a polynomial when you cannot factor. You have to pick a 0 off the graph and continue to break it down. So today we looked at a quartic, a cubic, and a quintic.